Hi students. Okay. So in this session we shall look at combinations. That means in the previous class we have done permutation. What is permutation? Then repetition of the elements in the permutation without repetition of the elements in the permutation, circular permutation, and problems on the topic of permutations are already over. Okay, so now in this session we shall go for combinations. Clear? So how the combination is going to be defined and what is the difference between permutation and combination, and coming problems will be very important on combinations. Clear? Okay, so now see here, combination means if we have n number of elements, we have n number of elements. Clear? So from this n number of elements I can take R, or I can take all n elements. Clear? We have n elements our side, so from that I am taking out of n, I can take any number of elements, that is R, or I can take complete n number of elements. That means I can take some number of elements from n, or I can take all the elements of that particular group or that particular elements. Clear? So by taking R number of elements, here I will make groups. See what I am saying? By taking R number of elements, I will make groups from this R number of elements. Are you getting my point? But in the permutation what we used to do, we used to arrange the elements. Clear? So for that reason, please see here, from n number of elements I am taking R number of elements and I am making groups from that R number of elements. That is what your combination. Combination means grouping the elements from given. Clear? Combination means making the groups of the element from the given elements. Are you understanding my point? So permutation was arrangement of the elements, but combination is grouping the elements from which you have. Clear? So that is called combination. Combination means taking R number of elements or n number of elements from n number of elements and grouping the given terms or grouping that elements is called combination, and its notation is given by Ncr. Its notation is given by Ncr. Clear? Okay. So I think now you got what is combination. Combination means there will be n number of elements, from that you should take R, or you should take complete all n number of elements and you make the groups of those number of elements. So that kind of experiments or that kind of procedure is called combination. Okay. So now let us go for the difference between combination and permutation. Clear? Okay. See here. Combination means it is grouping the elements. See? Combination and permutation. Combination and permutation. Clear? Combination and permutation. Combination means, first one, it is grouping the given elements. Grouping the given elements. Here permutation means arranging or arrangement of the given elements. Arrangement of the given elements. So what it is here, that is if you have A, B, C, D and E, that means you have 5 alphabets. Here also A, B, C, D, E. Here also you have 5 elements. So what they will do, take three elements from this, they will tell. What they will tell? They will tell, take three elements of this. That means you choose three elements. You choose three elements from this, they will tell. Clear? So how you are going to choose here? See, I will choose A, B, C. This is one combination. Clear? This is one combination. That is, by grouping three elements of this 5, you will have one combination. Again, you can write it as C, D, E. See, this is your second combination. So like this, you go on collecting three elements. Again, I will write one third one. That is A, D, E. So this is third combination. Are you getting my point? So like this, you can choose three elements and you can make groups from this 5. That is called combination. But permutation means, see, first here you have three elements. Okay. There were 5 elements. Out of that, while combination, what you have done? You have taken 3 elements. That is A, B, C. Here also, see what I will do. I will choose A, B, C. I will choose A, B, C. This is 3 elements I have taken from 5. But what these 3 elements will do here? See, I can arrange these 3 elements in different form. These 3 elements can be arranged like this. See here. I can arrange it as 1, that is A, B, C. Next I can arrange it as B, C, A. Next I can arrange it as C, C, A, B. Next I can arrange it as A, C, B. See, from these 3 only, like this I can go on arranging the terms. See, again I can arrange here. That is B, A, C. See, how I am arranging my terms. That means from these 3 only, like this I can write my permutations. Like this I can write my arrangements. See, what is the difference between combination and permutation? Here, if I choose 3 ABC, that one group is over. I can't do anything with these 3 elements. Next I has to go for other 3 elements. Next I has to go for other 3 elements. But in permutation, what it happens, if I take 3 elements from this 5, that is not enough for me, because if I choose these 3 elements, I has to concentrate on arrangements of these 3 elements. That is called the permutation. Clear? So how can I arrange these 3 elements out of this 5? See here, A, B, C first I can arrange, B, C, A I can arrange, C, A, B I can arrange, A, C, B, B, A, C. Like this I can arrange my terms from these 3 elements A, B, C. That is called permutation. But here, if I choose A, B, C, that's over. If I choose C, D, E, that's over. If I choose A, D, E, that's over. But here what happens? From this one group, you can make this many number of arrangements. From the second group, again you can make the arrangements. From third group, again you can make the arrangements. Clear, students? That is what the difference between permutation and combination. Clear? Permutations means arrangements of the 3 elements out of 5. Combination means grouping the 3 elements from the 5 elements. That is what the big difference between permutation and combination. Permutation is, second difference is what? Permutation is given by the notation, that is NPR, n factorial divided by n minus r factorial. Clear? But in the combination, it is given by NCR, that is n factorial divided by r factorial into n minus r factorial. Are you getting my point? So again you can say that by looking at this, the number of permutations are always greater than the number of combinations, because see, out of these 3 I am going on making these arrangements. From this one you have so many number of arrangements. I have just written the examples here. Clear? But I choose this combination, then it is over. But this one group will lead to this many number of arrangements. Clear? From this second group, again it has so many number of arrangements. From the third group, again it has so many number of arrangements. Are you getting my point? So each group leads to so many number of arrangements. But group is combination, arrangement is permutation. For that reason, always permutations, number of permutations are greater than the number of combinations. Please remember this. Clear? The number of permutations are always greater than the number of combinations, because from 3 elements I make so many arrangements. That is, I can see here I can make so many number of arrangements. Clear? That is 5p3. This will be the number of arrangements. 5c3 will be the number of groups. Are you getting my point? If you simplify this will be always greater than 5c3. Are you getting my point? So for that reason, please make a note that always permutations are greater than combinations. For example, see, from this 3, I can make 3 factorial number of permutations. How many I have written here? 3 plus 5. So one more I can write. One more, how can I write? Let us see. That is A 2 times A. Okay. C. This is B. C, B, and this is A. C, B, and A. See, these are the 6 arrangements I can write from this 3. Total from 5, I can write 5 factorial divided by 2 factorial number of arrangements. Here, I can write only 5C3 number of combinations. Are you getting my point? So, from this 5P3, 3 factorial, that means 6 number of arrangements from every 3 elements can be done. Are you getting my point? 6 number of elements, 6 number of arrangements from every 3 elements it can be done. Are you getting my point? So for that reason, permutations are always greater than combinations. Please make sure that permutations are always greater than combinations, because out of this 5 you take 3, from this 3 you can make 6 arrangements. Here if you take 3, that's over. That's one group, over. But the combination means, permutations means it is arrangement. Are you getting my point? So arrangement is always greater than grouping. So that's why permutation, number of permutations are always greater than number of combinations. Clear, students? Now let us go for the next topic. Okay, students. Now let us see at number of combinations without repetition. Clear? So that means from n number of elements or objects, from n number of objects, or number of objects are selected or grouped or made a group. From n number of objects, r number of objects are selected or made a group, then combination means NCR will be equal to n factorial divided by r factorial into n minus r factorial. That is, let us see here what happens. See, n number of objects are there, r number of objects are selected or made a group, then combinations are NCR equal to n factorial divided by r factorial into n minus r factorial. For that reason, let us see here. Let the number of groups must be equal to x. The number of groups must be equal to x. That means there are n number of elements. I have chosen r number of elements from n, and I made x number of groups. That means we are finding this formula. Let us find this formula. Clear? Now directly we have written through the definition, no problem. But how this formula comes? Let us look at that. Clear? Let the number of groups be x. In each group there are r number of elements. In each group there are r number of elements, that means R number of elements are taken and made X number of groups, so that each group contain R number of elements, each group contain R number of elements. This implies that R number can be arranged, arrangement will be equal to R factorial. Clear? In each group, R elements can be arranged in R factorial ways. Are you getting my point? That means we have X number of groups, in that R number of elements, that R number of elements can be arranged in R factorial ways. Now, total arrangements will be equal to X into R factorial. Total arrangements will be equal to X into R factorial. But we know that is arrangements are equal to NPR. We know this formula because always arrangements are equal to NPR, because R number of elements are chosen or selected from N number of elements, and we are arranging R number of elements, means the arrangements are given by NPR. That is what our formula. But according to here, we have X number of groups. In each group, R number of elements, which can be arranged in R factorial ways. From that we can say total arrangements are X into R factorial. But we know the formula of arrangements of R elements from N, that is NPR. Therefore, from these two, we can say that X into R factorial will be equal to NPR. Are you getting my point? Because these are the total number of arrangements. This is from the formula. So, X into R factorial will be equal to NPR. From 1 and 2, both the equations are equal. Clear? Okay. If I simplify this, what you are going to have? If I simplify that, X will be equal to NPR divided by R factorial. NPR divided by R factorial, and this term is N factorial divided by R factorial into N minus R factorial. See, this formula you are going to have. This is what here. That means X is what? Let the total number of groups equal to X. That means we were finding total number of groups. See, from this we were finding total number of groups where we had N number of elements. We were chosen R number of elements from N, and we were finding total number of groups. See how I have calculated here. We were finding total number of groups, that was X. Are you getting my point? So in that group, now I go on solving these things by using permutation. Here I go on solving using permutations to find how many groups. Clear? So until here we were looking at groups X. Now from this point I start to calculate the things by using permutation formula to derive your NCR. Are you getting my point? So for that reason, N groups there are, in the groups there are R number of elements. According to permutation, that R number of elements can be arranged in R factorial ways. Clear? That R number of elements can be arranged in R factorial ways. So, total number of the arrangements, if I want to calculate, X into R factorial will be total number of arrangements, because total X groups, in each group R factorial. So, if I multiply those two, it will be total number of the arrangement of your X groups. So, for that reason, total number of the arrangement is X into R factorial. From the formula, arrangements can be given by NPR. So that equation 1 and equation 2 both are equal. Therefore, X into R factorial equal to NPR. Therefore, X will be equal to NPR divided by R factorial. If I simplify that, you are going to have this particular formula, that is NCR equal to N factorial divided by R factorial into N minus R factorial. So this is what the formula for without repetition. Clear, students? I think you got formula NCR, that is N factorial divided by R factorial into N minus R factorial. So for that reason, now we have cleared how we are going to solve this NCR, how that NCR came. Clear, students? So now let us go further with some more topics, that is with repetition. Clear? Here it was without repetition. Now let us move for with repetition. Okay, students. So to simplify our first problem, that is 15C3R equal to 15CR plus 3, then the value of R is, okay. So what they are telling here, 15C3R equal to 15CR plus 3, then the value of R is. We know that NCR equal to NC N minus R. If you want to simplify, you simplify and check this term, no problem. So directly I take NCR equal to NC N minus R. By using this formula, for here I will get 15C3R will be equal to 15C 15 minus 3R. I am using this formula. Clear? So 15C3R equal to 15C 15 minus 3R. So from this we are going to have, this will be equal to 15C R plus 3. This is from problem. Clear? Here this is from formula. Further this will be equal to from problem. Clear? So now by this I can write 15 minus 3R will be equal to R plus 3, because NCQ will be equal to P will be equal to Q. So 15 minus 3R equal to R plus 3. Therefore it will be 15 minus 3 equal to 4R. Therefore R will be equal to 3. Therefore R will be equal to 3. See here. NCR equal to what? NC N minus R. If you want, you use the formula and simplify. You are going to have LHS equal to RHS, no problem. Further, 15C3R can be written as 15C 15 minus 3R by using this, equal to 15C R plus 3 from your problem. Therefore, from this we can write 15 minus 3R equal to R plus 3. Therefore, 15 minus 3 is 12 equal to 4R. Therefore, R is equal to how much? 3. Therefore, your answer will be 3. Answer is 3. Just because here you have to remember first and second. These two things you have to remember. Clear? So, if these two things you know, then the simplification will be very easy. Therefore, your answer will be R equal to 3. Clear? Okay. Okay, students. So now let us go for the second problem, that is everybody in the room shakes hand with everybody else. Clear? The total number of handshakes is 66. That means there is a room where gathered with some persons or some people where they are shaking their hands with each other, so that 66 number of total numbers of handshakes are done. Then the total number of persons in the room is, they are asking. Clear? There is a room with some people. Let us take n number of peoples. Those n number of peoples are handshaking each other. So those n number of people has done 66 number of handshakes. So now what is the value of n? They are asking. Clear? Okay. So that means, see here, there is a group of people with handshakes. Clear? Handshakes cannot be arranged here. They can do handshakes with anyone. Are you getting my point? Arrangement is not preference here. Clear? Handshakes are done with anybody else. Clear? So for that reason, it will be the grouping of handshakes. So total number of the handshakes are 66. We have n number of people. For one handshake, I need 2 persons. So NC2, the total number of handshakes is 66. Then what is n? Are you getting my point? For one handshake, I need 2 persons. From n number of people, I am taking 2 to complete my handshake. So total handshakes are 66. Are you getting my point? From n we choose 2 and total what we are getting, that is 66. Now we shall find what is n. So that is, this implies n factorial divided by 2 factorial into n minus 2 factorial, that is equal to 66. So listen here, n factorial can be written as n minus 2 factorial into n minus 1 into n divided by n minus 2 factorial equal to, you take 2 factorial on this side, it will be 132. Clear? So now n minus 2 factorial are cancelled. You will remain with n into n minus 1. Therefore you simplify by multiplying these two. Therefore n square minus n equal to 132. n square minus n minus 132 will be equal to 0. If I simplify this, you are going to have n equal to minus 11 and n equal to 12. n equal to minus 11 and n equal to 12. If I factorize these terms, therefore minus 11 is not your answer because the number of counting of people cannot be negative. Therefore your answer is 12. So therefore answer will be 12. Are you clear? See here, there are n number of people. For each handshake we need 2 persons. So here I want to calculate n, where we have total number of 66 handshakes. Clear? So for that 66 handshakes from n people, clear, I am going to calculate our n, that means total number of people. If I simplify this, you are going to have n square minus n minus 132 equal to 0, n equal to minus 11 and n equal to 12. So n equal to 12 will be your answer because n equal to minus 11 cannot be your answer just because counting of people will be not negative. Therefore n equal to 12 will be your answer. Clear? Okay students, now let us go for number of combinations, not permutations, number of combinations with repetition. Clear? Okay. Number of combinations with repetitions. That means, see here, from n number of objects are numbers of objects are selected where the same elements can be repeated, where the same number of elements can be repeated. Clear? That means you have total n number of objects, r number of objects are selected. Here I can write r or n. That means you can choose r, or you can take all n number of objects are selected where the same number of elements can be repeated. So first let us understand this with formula. Then we shall go for one of the problem so that this concept concept is going to be cleared. Without solving the problems, this particular concept is not going to be cleared just by reading the definition. Clear, students? So for that reason, let us solve one of the problem to understand this. No problem. Clear? So before that, see here what they tell. There are n number of objects. How many number of objects? N number of objects. From that they are choosing R, otherwise total n. Or they will choose R number of elements or complete n number of elements where a single element or single object can be repeated. Single element or single object can be repeated. That means, see here, what they are doing, from n, they can select 1. Are you getting my point? That can be repeated, 1. Next, from n, they can select 2. Again, that 2 can be repeated. Are you getting my point? From n, they are selecting 3. That 3 can be repeated, no problem. So on, they are going for n, c, n. Are you getting my point? So like this, they are gone making the selections. Like this, they are making on the selections. That means from this n, they can select 1 and they can repeat it. From this n, they can select 2 and they can repeat it. From this n, they can select 3 and they can repeat that 3 again and again and again. So on, from n, they can choose all n and they can repeat all those n. Are you getting my point? So for that reason, see here, first one, second one, third one. Now, if I want to calculate total number of the ways, means plus, plus, plus. So, these many number of ways are there to select and to repeat the same number of element. Are you getting my point? So that is equal to 2 to the power of n minus 1. 2 to the power of n minus 1. So this formula description you can solve on your own, otherwise you just remember it, no problem. nc1 plus nc2 plus nc3 so on to plus ncn equal to 2 to the power of n minus 1. I am not solving complete formula because just we need the formula for solving. If you want, you can try it on your own, no problem. Clear? But just let us remember the formula to further problems. That is, whenever there are n number of elements, they are choosing R number of elements and they are repeating out of those R. So then, what will be the total number of the ways to do so? They are calculating. Clear? So for that, nc1 plus nc2 plus nc3 plus nc4 plus nc5 plus nc6 so on to ncr plus so on to ncn will be equal to 2 to the power of n minus 1. Clear, students? So for that, let us take one example so that it will be very much clear to you. Clear? So for that, let us take one problem and let us try to simplify. Okay, students. So for this, let us see here. Clear? Okay. A man has 7 friends. A man has 7 friends. In how many ways he can invite one or more number of them for a tea party? Clear? Okay. Look at this. From n number of objects, R number or n number of objects are selected where the same elements can be repeated. Okay. Same elements can be repeated. Let us look later. But first you see this. From n number of objects, R number of elements, that means sum of this n, that means only few of this n he can select. There are total n. Out of that n, some of friends can be invited. N number of friends are there. Out of that n, only few or only some of the friends can be invited, or all the friends also can be invited. Are you getting my point? I am linking these two. Clear? there are n number of friends. Out of that n, he can select few, or he can select some of them, or he can select all of them for his party, because r or n number of objects are selected. Clear? Next, let us look at the same elements can be repeated. No problem. Same element means with only few he can do so many parties. No problem. Are you getting my point? But what we need here for one party, that is for T party, we are calculating of only one party, that is T party. The parties can be repeated, no problem. For that there is again more calculations. But here what we are doing for one party, parties may be repeated. For one party we have to calculate. For that one party, a man has 7 friends. Out of that 7, how many ways are there to invite one friend or more than one friend? Number of them. Clear? That means out of 7 friends, he can invite one friend or more than one friend for a tea party. Then how many ways are there to invite that particular that particular friends to his tea party, he is asking. Are you getting my point? So that means, students, see here, he has 7 friends. He can invite one person, plus he can invite 2 persons, plus he can invite 3 persons, plus C 4, so on to how much? 7C7. First you calculate 7C1, 7C2, 7C3, 7C4, 7C5, 7C6, 7C7, and you can sum all those. See, he can invite one friend, he can invite 2 friends, he can invite 3 number of friends, he can invite 4 number of friends, he can invite 5 number of friends, he can invite 6 number of friends, he can invite all 7 number of friends to his tea party, because what they are asking, 1 or more. 1 or more. According to our problem, I can write it as 2 to the power of 7 minus 1. 2 to the power of 7 minus 1. If you don't get this formula to remember, you can simplify all these terms and you can add. You calculate 7C1, sum with 7C2, you calculate 7C3, you calculate 7C4, you calculate 7C5, you calculate 7C6 and 7C7, and you make sum of all those. That term is going to be equal to 2 to the power of 7 minus 1. So 2 to the power of 7 minus 1 means that is 128 minus 1. 128 minus 1. So your answer is going to be 127. Clear? So that is your answer. So that is 2 to the power of 7 is 128. Clear? 2 to the power of 5 is 32. 2 to the power of 5 into 2, that means 32 into 2, 64. 2 to the power of 7, that means 2 to the power of 5 into 2 into 2 into 2, that is 2 to the power of 7. That will be equal to 128. Clear? 2 to the power of 1, 2, 2 to the power of 2, 4, 2 to the power of 3, 6, 2 to the power of 3, 8, 2 to the power of 4, 16, 2 to the power of 5, 32, 2 to the power of 6, 64, 2 to the power of 8, 1, 2 to the power of 7, 128. Clear? So 128 minus 1 will be 127. Are you getting my point? So your answer will be 127. I think now you got your particular definition and formula. Once again I am repeating this, so make a note of that. That means whenever there are n number of objects, from that n number of objects we are selecting r number of objects. There are n number of objects, we are selecting r number of objects. That means sum of that objects or n, total n, that means sum of the n or all the n. Are you getting my point? There are n objects. There are n objects. From this n objects, some selected or all are selected. All are selected. Why I am explaining? Because solving problem is important with understanding the concept. You may solve 100 problems, no worry. But if you solve those 100 problems without understanding the concept, no use. So for that reason, I am explaining in detail of that particular problem. That is, in this problem what we have solved, there were 7 friends. Out of that 7, I can select some of that. That means I can select a few, I can select more, no problem. Clear? Some of them or all of them. Clear? So there will be n number of objects, some will be selected or all the objects are also can be selected. In that particular situation, you should go through the formula NC1, NC2, NC3, sum of all these terms equal to 2 to the power of n minus 1. Clear? So, you may go on solving this type of problems in more numbers, then you will be very much perfect by solving like this. Otherwise, you solve one problem and understand the concept, that is also enough. You go on more number of problems of this kind, so again that will be more useful for you. Clear? Okay, now let us go for next one. Okay students, so in the previous problem we have seen from n number of objects, some of them are taken or all of them are taken. Are you getting my point? In the previous problem we have seen some of the elements are taken or all the number of elements are taken. Clear? But now let us see here the number of combinations n distinct objects. There are n number of distinct objects. There are n number of distinct objects are taken or at a time. That means from n number of distinct objects taken r number of elements at a time when any object can be repeated. When any object can be repeated for any number of times. Any object can be repeated for any number of times. Are you getting my point? So, this is very clear thing that you have to think. Clear? Okay, see here. There are n number of distinct objects. From that r number of objects are taken and any of that objects can be repeated for any number of time. That means, see here, for example, there are n number of elements. I will choose 0 number of elements. Clear? And I try to repeat that. As many as times. That means I can repeat it for n number of times. Are you getting my point? So on, see, here I can write x to the power of 0. That means this can be repeated for these many number of times. Clear? So on 2 plus nc1 x to the power of 1. Clear? This can be repeated for these many number of times. Total these can be repeated for n number of times. Are you getting my point? Next, nc0 x to the power of 0 plus nc1 x to the power of 1 plus nc2 x to the power of 2. This can be repeated for the n times. Are you getting my point? If I go on calculating like this, see, nc0 x to the power of 0 plus nc1 x to the power of 1 plus nc2 x to the power of 2 plus so on 2, that will be x to the power of n. Here the coefficient complete whole to the power of n. Are you getting my point? This term will give you the number that can be chosen from the R number of elements, and they can be repeated for so many number of times. That means n number of times. It is very essential to understand that. See, if I choose one x, here it can be repeated for this times. Total we have n, complete to the power of n we can repeat. Clear? So like that, if I choose this many number of elements, and in the nth element, the coefficient of nth element tells us that the total number of, see, the total number of combinations of n distinct objects taken are at a time, and at how many, at any number of times it can be repeated. Again I am telling, if I solve the problem, then this is going to be clear to you. Without solving the problem, this problem is not going to be clear to you. No problem. For that, I will solve more than 2 or 3 problems. It will be very clear. Again, I am telling you, there are n number of elements, r number of elements are taken, so that such a case where that r number of elements can be repeated for any number of times, such that r number of elements can be repeated for any number of times, then how to find the total number of ways we are calculating here? Clear? So for that, first thing is, I am calculating this. I will take one x and I will repeat it. How many times I can repeat? N number of times I can repeat. The coefficient will give me that value n. Clear? If I go for x to the power of 1, are you getting my point? Here x to the power of 0, here x to the power of 1. These two can be repeated for how many times? nc 1 times. Clear? Because this is the final coefficient of x. Are you getting my point? First the coefficient, power of x was 0. Here power of x is 1. This can be repeated for these many number of times. So now x can be repeated for nc1 number of times. X square can be repeated for nc2 number of times. So like that, n number of elements can be repeated for these many number of times. Then what is that coefficient? That is coefficient of x to the power of n is equal to n plus r minus 1 cr. This will give you how many number of times, from the n number of elements, r number of elements are taken, and that r can be repeated for any number of times. Understanding is very important. If you don't understand, I will solve some problems. From that problems, you can get the answers, so that the problem, this particular thing will be very clear. Now remember that coefficient of x to the power of n is n plus r minus 1 cr. If you remember this, then your problems are going to be very easy. That is n plus r minus 1 cr. These things are going to be very easy if you remember this formula. Clear? So for solving the formula is very important. By solving the problem, we can understand the concept. I have explained the concept, no problem. If you understand, no problem. If you don't understand, no worry. I will solve the problem. Then this particular concept is going to be very clear, as in previous one. When I explained my theory, that time it was not clear, but by solving the problem of friends invited for tea party, you understood what is concept. Clear? So along the same way, now I will solve the problems on this, so that you can understand the concept. Clear? So if you now you are not understanding the concept, no problem. When I solve some of the problems, then the concept will be very much clear. So let us go for the problems. But you remember this formula, coefficient of x to the power of n is n plus r minus 1 cr. Clear, students? Okay, students. So listen very carefully whenever I am explaining this particular problem, because from this problem we are going to understand one of the very important concept which I have already explained. For more number of students, that concept will be not clear. If clear, it is no problem. But for more number of students, the concept will be not clear. But whenever you solve an example, then every concept is going to be very clear. For that reason, we should solve more number of problems. Now, no worries. Okay, let us understand this. See, the total number of ways of selecting 6 coins. That means you are selecting 6 coins. Please understand, you are selecting 6 coins. Clear? Out of 20 1 rupee coin. See here, there are 20 coins of 1 rupees. Clear? Next, 10 coins of 50 paise. Clear? 10 coins of 50 paise and 7 coins of 25 paisa. 7 coins of 25 paisa. Clear? So, now what they are asking, the total number of ways of selecting 6 coins. Total number of ways of selecting 6 coins. Have you understood my point? 20 coins of 1 rupees. 10 coins of 50 paisa, 7 coins of 25 paisa. Out of this, you should select 6 number of coins. You have to select 6 number of coins out of this. Are you getting my point? So, you go through the previous video. There, you've seen that n number of distinct objects. Are you clear? You just go through the previous statement that there we have written from the n number of distinct objects, r number of objects can be taken, or that r number can be repeated for any number of times. Are you clear? See, again I am telling, there are n number of objects which are distinct. That n was distinct. From that distinct number of objects, r number of objects are taken. From the n number of distinct objects, r number of objects are taken, and that r can be repeated for any number of times. Clear, students? So it's a very clear statement that if that kind of things are done, then our formula was n plus r minus 1 CR. Clear? n plus r minus 1 CR. Clear? n plus r minus 1 CR was our formula, where n number were distinct objects, r number were taken from this n, then this r can be repeated for any number of times. Then we used our polynomial function to calculate the coefficient of nth object. In that, we constructed one polynomial by using our expansion formula, and we said that the coefficient of nth term will give you the required answer. That was the explanation of my previous theory. Clear? So that's what we are using here. See, there are 3 number of distinct objects here. What are the 3 number of distinct objects? 1 rupee coin, 50 paisa coin, 25 paisa coin. These are the 3 distinct objects. Are you clear? So from these 3 distinct objects, you can choose 6 number of coins. Clear? From these 3 distinct coins, you can choose 6 number of coins, because these 3 distinct will give you, see, 37 coins you have in your hand. That is not important. 37 you have, that is not our important term to solve answer. Some of the students will write 37 here. That's not 37, that is 3. According to our theory, distinct objects are n. So, n value will be 3, r value will be 6. Selections, minus 1, C, 6. Clear, students? So, understanding the concept is very, very important. So, here, n will be 3 plus 6 minus 1, C6. Clear? So 6 plus 3, 9, 9 plus 1, 8. So that will be 8C6. So 8 factorial divided by 6 factorial into 8 minus 2, 6 factorial, 6 factorial, 6 factorial cancel. So it will be equal to what? 7 into 8. 8 minus 6, it will be 2 factorial. 6 factorial, 6 factorial cancelled, 2 factorial, 2 into 1, 2 into 4, so 7 into 4, it will be 28, so it will be 28. So understanding the concept is very, very important, my dear students. So here, I think now the concept is very much clear to you by looking at this particular problem. So as you go through that theory also, you can understand this problem. You understand this problem and you can apply to that theory, no problem. So whenever you are solving the problems, your theoretical concept will be very easy. Clear? So please remember, whenever there are n number of distinct objects, from that r terms are taken or r objects are taken, and that r objects are repeated for any number of times. R objects can be repeated for any number of times, so that repetition of any number of times can be calculated in the number of ways with n plus r minus 1 c r equal to, that is the coefficient of x to the power of n in the expansion of your polynomial. Clear, students? So I think now you cleared with your this type of combination with repetition. Clear? All these type of problems are very, very important for your exams. So try to solve more number of problems of this kind on your own. So it will be very easy. Okay, students. So now let us solve one more problem on the statement that from n number of distinct objects, r number of objects can be selected, and that r number can be repeated for any number of times. That number of combination we are going to calculate here. So see, the number of ways in which 35 apples can be distributed. Here distribution, selection are both are same. Clear? So distributing, selecting, that all are synonyms, so no problem. That is, distribution means giving, spreading. Clear? Selections means again that the same kind of problem where we are relating here. Selecting 35 or distributing 35, no problem. So for that reason, here r will be equal to 35 because this is distributed. Clear? Can be distributed among 3 boys. See, 3 different objects. Apples are same, no problem. 3 different objects, those things are means n equal to 3. So that each can have any number of apple. As I said, r object can be repeated for any number of times. Here they only telling that each can have any number of apple. That means r can be distributed for any number of times, that we have understood. Here in the problem, they only telling for more clarification that r will be apple. R will be apple because that can be repeated for any number of times. The boys can take any number of apples. A single boy can take all 35. Are you getting my point? A single boy can take 0 apple. Are you getting my point? From 3 boys, boy 1 can get all 35 apples also. The same boy 1 can also be with no apples. Are you getting my points? That's what the beauty of this particular problem. Clear? So that means a boy 1 can take 35, boy 2, boy 3, no apples. Boy 2 can take 35, boy 1, boy 3, no apples. Or they can distribute like 10, 15, 10. Like that also they can distribute. These are all types of distributions. Clear? That kind of distributions are how many they are asking. Clear? So for that reason, n will be the number of boys, r will be the number of apples. Therefore, n plus r minus 1 cr equal to n is 3 plus 35 minus 1 c 35. So this will be 37 c 35. So that is nothing but 37 factorial 35 factorial into 2 factorial, 35 factorial, 35 factorial cancelled, 36 into 37 divided by 2, so it will be equal to 18 into 37, so 18 into 37 is nothing but 666, so it will be equal to 666. I think now the concept is so much more clear. I have understood the point. So please make a note that when n number of objects are there, from that r are taken, clear, or r are distributed according to this, clear, r are selected, or according to this r number of elements are distributed, where r can be repeated for any number of times. R can be repeated for any number of times. That number of ways can be calculated with n plus r minus 1 cr. This is one formula, and this was second formula. First was 2n minus 1. In this, some are taken, or all are taken. Some are taken, all are taken. In this, see the second one, that is from n r are taken and repeated for any number of times. These two are two different formulas which you should remember with problems. Clear, students? So from n, r are taken and repeated for any number of times will give you n plus r minus 1 cr. Some are taken, that means from n, some are taken or all are taken will give you 2 to the power of n minus 1, and this from n, r are taken and repeated for any number of times will give you n plus r minus 1 cr. So these are the two different important formulas for the combination topic. So that I think you will remember two important problems, important topics with the two important formulas with some of these problems, so that your particular things are going to be easy in your exam. Clear, students? Okay students. So now let us go for the next problems. By understanding those two concepts, now let us go for the next problems. Clear? Okay. So see here, 15C8 plus 15C9 minus 15C6 minus 15C7 is equal to what they are asking. Clear? Okay. So if you go on solving 15C8, 15C9, 15C6, 15C7 will be very lengthy problem, because you have to calculate everything and you have to subtract. But let us look at the formula which we have studied already, that is NCR equal to NC n minus r. This formula we know. Why? Because see here, 15 minus 8 is 7. 15 minus 9 is 6. Are you getting my point? Those two terms are present here. So 15 minus 8 is 7, 15 minus 9 is 6. So for that reason, by using this formula, how can you write 15C8 is equal to 15C7? Clear? 15C9 is equal to 15C6 by using this formula. So from using this formula, you can write these two terms. See here, 15C8 equal to 15C7. That means these two terms are same. 15C8 and 15C7 both are same. 15C9 and 15C6 both are same. So if I cancel these two and these two terms, so your answer is going to be what? Your answer is 0. Therefore 0 will be your answer for this particular question. Okay, here the options are 15 plus 8, 15 into 8, option C is 15C8, and option D is none of this. Clear? Okay. So in how many ways can a girl or a boy can be selected from the group of 15 boys and 8 girls? They are asking. Okay. So total from 15 boys you have to select. How many boys and girls can be selected from a group of 15 boys and 8 girls? In how many ways can a girl and boy be selected? That means one girl and one boy has to be selected. See here, in how many ways can a girl and boy, a girl and a boy has to be selected? That means one girl and one boy has to be selected from the group of 15 boys and 8 girls. So he can select any boy, no problem. He can select any girl, that is also no problem. So that means from 15 boys, one boy has to be selected. From 8 girls, one girl has to be selected. Then the total number of the ways means multiplied. Clear? So this will be equal to 15 factorial, 1 factorial, 14 factorial multiplied with 8 factorial, 1 factorial and 7 factorial. So this will be equal to, here this is 15 into, here this will be 8. So your answer will be B. Your answer will be B for this particular question, because here they are selecting one boy and one girl from total of 15 boys and 8 girls. So from 15 boys, one boy has to be selected. From 8 girls, one girl has to be selected. So from that you can say that 15 into 8 are the total number of the ways of selection of a girl and a boy from 15 boys and 8 girls. So your answer is B, that is 15 into 8.